Hello and welcome to this new lesson. This is like an introduction lesson to this course. We will talk about what is object-oriented programming, and we will talk about the end result that you will get after finishing this course. Object-oriented programming is a computer programming model that organizes software design around data or objects rather than functions and logic. So basically, what you will do when using object-oriented programming with your Arduino codes is turning your simple code, like the one you can see here on the left, to object-oriented program or code, like the one you can see here on the right. Now, let's start with stating the obvious. As you can see in here, we have the setup function, and this is our INO file. Now this file have two simple lines. The first one is the output, and the second one is the output, which is the pin mode function for pins number 2 and 3. So here we are setting pins number 2 and 3 as output. Now, when it comes to these lines inside the loop function, we are basically turning the lid on and off at a delay of 1500 milliseconds. We are doing the same for lid number 3, or for pin number 3, which has a lid at 2000 millisecond rate. So this is a blinking lid, and this is another blinking lid. This is a red lid, and this one is a green lid. So this is a simple program, and we want to turn it to OOP, which is object-oriented programming. And to do that, we have to do a few things. The first thing is to make our code object-centered. Now, this is a simple code with few lines, so we need to make sure that we have classes and objects to make our Arduino code object-oriented. Now, we have 3 files here. This is the first one, this is the second one, and this is the third one. The first one is the main INO file, which is our Arduino project standard file. Now the second one is the header file, and the third one is the source file. Now if you did use Arduino libraries before, then you must be familiar with these terms, the header and the source file. Now, the header file will include the prototypes for functions and for almost everything you want to use, while the source file will include implementation. Now, every Arduino library or every C library must have these two files, a header and source file. Now, this INO file is the project file. We call it a project file here for simplicity. Now, let's get started. The first thing that we do is the header file. We include header guards, and these header guards must have the same name, as you can see, my class, and we will use the same name here when we call the header file in our main project. These header guards are used in C for different purposes, and if you know C programming and embedded C, you must know why we are using them. Now, they are basically to make sure that the class or the file is defined and it's not duplicated. Now, there are other uses as well. You can check our course in embedded C to see that. Now, the first step is including the Arduino.h or the header file, which is the main Arduino file that has all the Arduino functions, like the, let's say, pin mode and other functions. So we need to include it because we are creating a new file and we need to use functions inside this file. So after including Arduino.h, you will see that we are also including it inside our source file. So this is like a default sentence that you must add on both of your Arduino files, header and source. Now the next step is creating your first class. And to create a class, it is a very simple process. Simply write class and then the name, then add two curly braces and a semicolon. Now the name of the class must match the header file name, which is basically my class that we used here and here. And this is a very important note, because if it was a different name, we will not be able to create objects. Now, let's go to the next step, which is creating the prototypes. Now, in Arduino libraries or in C libraries, we usually create prototypes right away, but here we will create them inside the class. The first step is adding two words, public and private. Now, public with two dots and private with two dots. The public here will include the public functions that we can call inside this project file. The private will include variables and functions that we will not be able to access using the project, but we will be able to access them in the source file. And this is a very important note when splitting your, let's say, functions, your variables among the public and the private. They are basically a way to define the security level for functions and variables. So my class function is the first function, and the second function is called my function. Now the my class function has the same name as the class and as the file. So you need to make sure that there is a match in the name between this function, this word here, and these two words here, and the name of the header file, which is in this case my class. This is to make sure that we can create an object from the class. Now we are sending a simple value, which is end pin, for the pin number to this function. We also created a function that returns nothing but takes the blink rate. So this will be responsible for the pin number, and this will be responsible for the blink rate, which is how fast our lid can blink. Now the next step is creating a private variable, which is end pin. Now most of the private variables, the naming convention for them is adding underscore, then the variable name. And we'll talk about that variable in a minute. Now this variable can only be accessed in the source file, and there is no way that you can access this variable inside the project file. Now let's go to the third file, which is the source file. Now the source file is where you write your functions implementation. So we included Arduino.h and we included myclass.h, which is the header file that we already created here, to make sure that we have access to the prototypes of these functions. Now we will add the functions code exactly like what we do in embedded C or C libraries. We will write the function name, we will write the input just like here, but instead of the semicolon we will add two curly braces and our code will be inside here. Same thing goes for here. We will remove the semicolon and we will write the code inside here. Now the only thing that is different in this case is this word. As you can see, we have my class, two colons, and then the function name. You need to make sure that you are stating the class to which this function is, let's say, attached. We created this function inside the my class, so we need to make sure that we have my class and two colons before the function name. Same thing for the second function. And this is a good way so that we can know which class has which functions. So make sure to mention the class name before the function name and separate them by two columns. Now this code is straightforward. We are basically writing high and low to the pin that we are using with the blink rate that we are adding here as input to the function. Now, here we have something that we need to explain. The pin mode function will take the input pin and it will also set it as output. So if we added 2, it will be pin number 2, treat it as output. But this is the line that we need to look at. Now we already mentioned that this variable can only be accessed inside the source file. In order to access this variable and to make it usable, we will assign the value of the pin, which is the input value, inside our main function here. And we will make it equal the private variable, which is the underscore pin, so that we can use the underscore pin inside this function without any problems, as you can see here and here. So we created a private variable, we assigned a public variable to the private variable, then we use the private variable inside our source file. Now we created the source file, we created the header file. The third step is using all of these inside our project file. First, you need to include myclass.h, which is the header file. Then you need to create two objects. This is why it's called object oriented. This is the first object and this is the second object. The first object is called myclass read2. So this is the name of the object and it takes an input, which is a number. And as you can see, the number will be the pin number here on the right. Same thing for the second object, myclass green3. It will be the pin number for the green LED. We won't write anything inside the setup function, but here in the void loop, we will call the functions inside the objects. Now, since we created an object, it will have the same features as the class that we created the object from. So it can access the functions. And as you can see here, we have read.myFunction, which is one of the functions inside this class. So read.myFunction and the blink rate, green.myFunction and the blink rate. And this is basically how you can turn a simple code written in C++ into an object-oriented code. Now, let's summarize what we have said so far. The first thing that we mentioned is that, okay, let's make sure that this is not hiding. Okay, great. Now, the first thing that we did is creating the header file. Now, after creating the header file, we added the header guards with the same name as the header file. After that, we included the Arduino header file to make sure that we can use all the functions and variables that are introduced by Arduino. Then we created a class with the same name as the header file and the header guards. We added public and private. Public, we will add anything, any function, any variable that we want to use inside this project, inside the public. But any variable or function that we do not want to allow access to it from the project file, we will place it inside the private. Now we created two functions, myClass, which has the same name as the class and the header file, and the other function is called myFunction to control the blink rate. So myClass will control the pin number and myFunction will control the blink rate. Then we created a source file with the same name, but it has a different extension .cpp. Now we included the Arduino.h and myClass, which is basically the two header files for Arduino libraries and for myClass, which is the one that we created here. Now we call the function just like in C, here and there. This is the function implementation. And we wrote our code without any problem. We did the same thing here. But since this is a function inside a class, we had to write the class name and the two colons here and there before the function name, so that we tell the program that this function is a part of this class. Now, one more thing that we needed to explain is that we assign the general public variable value, which is pen, to the underscore pen, which is the private value that we created here. This is because we wanted to, let's say, make sure that we can access it inside our function. Once we are done, we call the header file. Then we created two objects, red and green, and we added 2 and 3 as the pin numbers. Now you have to write the class name before the object name. Then we use the objects. Since these objects from the class called my class, they have access to the functions inside it, so they can access the my function and my function, and we send two blink rates. So this is basically how we turned a simple code into an object-oriented code. We created two objects, red and green, with 2 and 3, which are the pin numbers. Then we use these objects that has the same features as the class to use different functions that are defined inside that class. Now, if you missed anything in this lesson, we will explain things in more details in the coming lessons as we are writing the code one by one together. Thanks for watching this lesson. This is Ashraf from Educational Engineering Team.